This video is in response to the questions of students about the angle theta in this example. So why 240 degrees and not 60 degrees? Okay, so allow me to explain this example again. So we are going to evaluate -1/2 minus square root of 3 over 2i, and this complex number is raised to +3. So for us to do it, we need to convert this rectangular form of complex number into polar form. And then we apply the Moivre's theorem. But the question here that I'm going to emphasize is, okay, why 240 and not 60 degrees? Because if you are to check in your calculator, arctangent of square root of 3 is 60 degrees, not 240. So let me explain why use 240 degrees. As you know, -1/2 minus square root of 3 over 2i, this complex number is located at the third quadrant. So let me show you. So let me draw, the complex plane. The horizontal axis is the x-axis or the real axis. The y-axis, the vertical axis, is the imaginary axis. It is important that you know the location of this complex number in the complex plane. So we have the real part, x here, is equal to -1/2. And y, the imaginary part, is negative square root of 3 over 2. Now, if you plot the complex plane, so we have x is -1/2. This is the negative x of the x-axis, negative side. This is the positive side of the x-axis, positive of the imaginary, and negative y-axis. So we have 1. Okay, this is -1. And this is -1 for the imaginary axis. X is -1/2. This complex number is located somewhere here, and negative square root of 3 over 2. So it's 0.8 somewhere here, 0.8 something. So it means that the complex number -1/2 minus square root of 3 over 2i is located in the third quadrant. Now, again, this video is for me to explain the argument theta. So if you get arctangent of square root of 3, you will get +60. So +60 is located here. So a reference is on the positive x-axis. The argument 60 degrees is located in the first quadrant. Okay, but we're talking about this complex number. It's in the third quadrant. Using this reference, counterclockwise direction, from here up to this angle theta, this is equal to, if this is 60, means that this part is also 60. So from this point to the negative, we have 180 plus 60. So we have 240 degrees. That's why we should use 240 degrees, because the complex number -1/2 minus square root of 3 over 2i is located at the third quadrant. If you use +60, it means that your complex number is located in the first quadrant. Okay, if you still insist to use positive 60, it will give you, okay, 60 times 3, 180, and cosine of 180 is negative. So it's the opposite. That's why be careful in determining the argument if you are to use arctangent. But if you directly use your calculator in converting the rectangular form into polar form, it will give you a negative angle. It's okay to use that as long as you're aware of the direction. It's actually negative 120 if you do the direct conversion. So negative 120 is, yeah, clockwise direction. This is negative 120. Okay, so this is the result, the theta that will appear in your calculator if you directly convert this rectangular form into polar form. Okay, so I hope this answers your question. So now that we have theta equal to 240 degrees, we can now apply, of course, we have the absolute value can be determined by the square root of the sum of the squares of the real numbers. Square of the real part, that is 1/4, and square of the imaginary part, or the real number in the imaginary part, and that is square root of 3 over, negative square root of 3 over 2 raised to 2, and that will give us 3 over 4. 1/4 plus 3 over 4 is 4 over 4, and that is 1. Square root of 1 is positive 1. So the absolute value, or the modulus, is 1. And then using cosine theta, the polar form, plus I sine theta, we plug it in here, and then since this complex number is raised to a power of 3, we can apply, the r will be raised to 3, and the arguments will be multiplied by the value of exponents. So 3 times theta, in this case, so we have cosine 720, and cosine 720 is positive 1. Sine of 3 times 240, we have sine of 720. So sine of 720 is 0. That's why we have a real number equal to 1. That's all.